So here's an example to kind of illustrate how we use corollary 3. And this says find a function f of x whose derivative is the sine of x and whose graph passes through the point 0, 2. Now, the notation on this is a little bit confusing at times because we switch back and forth because we're not always sure what we're talking about. Are we talking about a function or a function whose derivative is something? So we'll kind of specify the notation we're going to use probably in the next set of notes I give you. So in the next notes, probably 4.2e, we'll talk about actually how we're going to notate these things called antiderivatives. But right now, we'll just use this notation as this is an example. I think this is the one they used in the book. So find f of x whose derivative is sine of x. So the derivative of this function will be sine of x. We're trying to find the function whose derivative is sine of x. We're going to be going backwards. And then whose graph passes through this point. So we'll just use these corollaries so you can see how we apply these. Okay? So we know the derivative of this function, f prime of x, equals the sine of x. All right? Okay, so by corollary 3, we know that f of x equals g of x plus c. All right? In other words, this is some other function that has the same derivative, but they only differ by a constant. That is f prime of x equals g prime of x. See, if you take the derivative of both sides, it's going to be f prime of x, this will be g prime of x, and the derivative of c will be 0. So that makes sense. All right? Now let's go back and try to figure out what function is going to have a derivative of sine of x. So let's go back and kind of review. We know that the derivative with respect to x of the cosine of x is negative the sine of x. So we're almost there except a negative sign. Okay? In other words, we're looking for f of x. Well, if f of x was the cosine of x, the derivative of the cosine of x is negative sine of x, well, we're almost there. Okay? So we know that the derivative with respect to x of negative the cosine of x, which is the same thing, and I can take that negative sign out and put it in front, is negative the derivative with respect to x of the cosine of x. What's that going to be? Well, that's going to be negative, and the derivative of the cosine of x is negative the sine of x, right? And a negative times a negative is a positive, so that equals the sine of x. So it looks like negative cosine of x will work. In other words, if f is negative the cosine of x, the derivative of that will be sine of x. And that pretty much satisfies what we want, except we have to take into consideration what's happening because we could have it could be something else. It could be like negative cosine of x plus 4 plus 5 plus 6. We don't know because there's going to be a constant involved. That's the whole trick. So I can say that g of x, if that equaled negative cosine of x, then that would imply that g prime of x would be equal to sine of x. So now we've got two functions, g of x and f of x, that have the same derivative, sine of x. But again, by corollary 3, we know that f of x equals g of x plus some constant. So therefore we can say that f of x equals g of x, which is negative cosine of x, plus c. And you can always check that if we take the derivative, what's f prime of x? That's going to be, and remember the derivative of the cosine is negative sine, so negative sine is positive sine, and the derivative of that will be 0. So we can say this implies that f prime of x equals the sine of x. Okay, so that's what we were looking for. Okay, and when you're doing the what we call the antiderivative worksheet, I gave you numbers 1 through 24. Our problem's just like this. We're just going to go backwards, but we have to remember that constant is going to be in there. And we'll go more through the notation, like I said, on the next set of notes. Now, this problem gave me a particular point that my function goes through, that f of x goes through. So we know the derivative is the sine of x and it goes through this point. So we can actually find what the c is. And that's what we do in the next set of problems on the antiderivative worksheet. Okay? And we'll do those a little bit later, but let me give you an example. So since we know since the point 0, 2 belongs to our function f, right over here, 0, 2 belongs to f of x. And that really means that f of 0, if I put 0 in here, what do I get? That's what equal to 2, right? So if I put 0 in for x, every time I see an x, I put a 0 in, then the f of x will be equal to 2. Oops, sorry, that's 2. I'll write that down and maybe fix that. F of 0 equals 2. I got my whiteout near. And I do these things in ink so you can, it's a little bit easier for you to see them, but then if I make a mistake, it's a big old mess. So we know that f of 0 equals 2. Okay. So what I can do is with this data, I can take this function over here, and I can write what I have over here. F of x, I know, equals negative the cosine of x plus c. And then every time I see an x, I'm just going to put a 0. And I know f of x, this is f of 0, equals 2, so I know that this would be 2. And that's going to be equal to negative the cosine, and that's when x is 0, of 0, plus c. All right? So just kind of watch your notation. 0, 2 belongs to f of x. That means f of 0 is 2. Well, this is f of x, so f of 0, if I put 0 in there. Oh, I should have put that in first. Yeah, this would be a little bit better. There we go. Okay, so f of 0 equals negative the cosine of 0. And I know that f of 0 is 2, so 2 goes there, and 0 goes there. And that means that 2 equals, and what's the cosine of 0? The cosine of 0 is 1. That's going to be negative 1 plus c. And then if I add 1 to both sides, then c equals what? 2 plus 1 is 3. So I know what the c is. So now I know that I can put that back in my function. Because we know that f of x, we can just put that right back in there, and then we can say that f of x equals, and then just the negative cosine of x, and then plus c, but what's my c? My c is 3, so. And these are the next set of problems to actually find what the value for c is. Okay? So hope that helps.